think so, yes.
Yeah, okay. So, good morning, everyone. Yesterday we discussed one principle for uh, counting, which was the addition principle, Mm, Okay. We also did some problems there, and then we also looked at what is the multiplication principle. So the multiplication principle is, so if I have 9 varieties of cakes and then 6 varieties of ice creams, if I had to choose, one cake and one ice cream and one ice cream, then we have the number of choices will be 9 into 6. Okay. This also we saw. And suppose I have, let us say, 5 people to be seated in a row. So I have to fill up 5 slots, 1, 2, 3, 4, 5 slots. And then the first slot can be filled in 5 ways. And then the sixth slot can be filled in 4 ways. This is in 3, this is 2 ways, and this is 1 way. So by multiplication principle, it is 5 into 4 into 3 into 2 into 1, which is usually written as 5 factorial. Okay. Now I have, let us say, 10 people, but I have only 3 chairs. So how many ways I can seat 3 of these people in this one? So here this I have choice of 10, this I have choice of 9, this I have choice of 8. It is 10 into 9 into 8, which is whatever, that's 720 or whatever. Okay. It's basically this is placing, or let us say arranging people in a row. Right? So please see, sir. Now, if I want to choose 3 persons out of 10, 3 persons out of 10, okay? So how will I choose that one? So 3 persons out of 10 I have to choose. And what I will do, I will do this in 2 ways. Meaning what I will do is I will do something in 2 ways, and from there I will derive this number. Suppose I want to arrange uh, 3 out of 10 in a row. That I already have seen as can be done in 720 ways, but I can do it in a different way. What I will do is that I will choose 3 people first, and then arrange them in a row. So how many ways I can choose 3 people first? Suppose that I do not know that yet. So if that is n, and once I have chosen 3 people, how many ways I can arrange them? That we already know, which is 3 into 2 into 1. So if I choose first and then arrange, the number of ways becomes 6 times n. If I arrange directly, I have 720. So these two should be the same. So I have my 720 is equal to 6n. Therefore, n, which is the number of ways of choosing, is 720 by 6, which is right, that I can written, that is written as 10 into 9 into 8 by 1 into 2 into 3. Now, instead of 3 and 10, suppose I have, let us say, 5 and 15. Same way, it will be 15 into 14 into 13 into 12 into 11. And suppose if I can choose 5 people in n ways, and these 5 people can be arranged in factorial 5 ways. Therefore, my factorial 5 into n must be equal to 15 into 14 into 13 into 12 into 11. So my number of ways of choosing is 15 into 14 into 13 into 12 into 11 divided by factorial 5. Correct? So more generally, if I have n people or n things, whatever, And if I want to choose R out of that, or out of this, the number of ways is n into n minus 1, etc. I have to multiply R terms here divided by 1 into 2 into 3, etc. up to R. So the last term will be, the first term is n minus 0, second term is n minus 1, third term is n minus 2. So the rth term will be n minus r minus 1. So it is n minus r minus 1. So so this is same as n into n minus 1 up to n minus r plus 1 divided by factorial r. I can also write this as n into n minus 1 up to n minus r plus 1. I will fill this sum n minus r extra up to 1 divided by 1 into 2 extra up to r. This is what I have added in the numerator. So I have to divide by the same thing. And this one is n minus r factorial. So the thing is n factorial. So I can also say that n factorial by r factorial into n minus r factorial. So this is the number of ways of choosing r out of n. So is this clear?
Yes, sir.
So r out of n. So this is actually what is called the NCR. That is n choose r. This is one symbol which is usually used. We'll basically use this kind of thing. That is a big bracket with n and r put like this. So for instance, if I want 10C2, so instead of, we will use, most of the time we will use this formula. That is, we'll start at 10 and then go up to 2 terms and divided by factorial 2. It will be 10 into 9 by 1 into 2. So this is what. Similarly, if you want 7C3, this is 7 into 6 into 5 by 1 into 2 into 3, which is 7 into 5, which is 35. So this is what is, okay, this is what NCR is. This is N choose R. These also have a different name called binomial coefficients. These are also called binomial coefficients. Because these terms will also come if I just expand this a plus b whole power n. Okay, anyway, we will not go into that now, right now. So this n choose r is the number of ways of choosing or choosing r people or r things out of n things. Okay, and let us see some. One second, because this is, yeah, okay. Right. 1 minute. No, not this. This also, no, I have. 1 minute. Just I forgot where I kept that. No. Where was that? Oops. Yeah. Okay, well, we did this problem before, right? Let me clear this things up. So clear this up.
Sir,
Yeah.
is it possible you to for turn on your camera so we can spotlight you?
For a second, because as I said, I tried to use my laptop, but it's not working that well. But let me check. I will turn it on for some time and then we can.
Okay, okay.
Yeah. Is that okay? Am I visible?
Okay,
Yes.
sir.
Yeah. Okay. So let me go back. Yeah. Let me go back to the, sorry, I will turn this off. Oops. Yeah. Okay. Right. So this problem we did before, that is if I want, so I want to find the number of shortest paths between A and B. And we did a simple addition principle counting like this. So we just listed them down and then looked at how many numbers are there here. Okay, that was the that was the style which we did. But here what we can do is, now that we know multiplication principle and I know how many ways and so on. So what I have is that I have to fill 10 steps, correct? There are totally 6 here and then 4 here. I have to fill up 10 steps. Each step could be either towards the east or towards the north, that is towards this guy and towards this way. And how many of this will be there? How many of this will be there? There will be 6 of E and then 4 of N. There will be 6 of E and 4 of N. So I have 10 slots to fill. I have 10 slots to fill. Out of these 10 slots, 6 must be reserved for E and then 4 must be reserved for N. There could be anywhere. There could be anywhere. So out of 10, I will choose 6 of them in 10C6 ways and then fill them with E. Fill it with E. The remaining 4 of them, there could be anywhere. It could be E here and then E here, E here, E here, and E here, and E here. The remaining will be N, 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 N. So this will give me a shortest path. For instance, this path will be given by, this will be this path will be east first, and then I have north, and then I have east, and then I have north and north, then I have 2 east, then I have a north, and then 2 east. So this path would be represented by this sequence. So every such sequence will be one path like this, which contains exactly 6E and 4N. Therefore, the number of paths is basically 10C6, which is same as 10 into 9 into 8 into 7 into 6 into 5 by 1 into 2 into 3 into 4 into 5 into 6. So 5 and 6 I can cancel out. This I can cancel out. And this I can cancel out. So I have 210 as before we got the same answer. Correct? I got the same answer. Right? Okay. Now let's look at one more problem. Yeah. Oops, 1 second. Yeah. Let's look at this problem. So how many ways I can arrange the letters of the word? Okay, how many ways I can arrange the letters of the word daughter so that no two vowels are together. So that no two vowels are together. So what are the vowels here?
A, U, and E.
I have A, U, and E. So these should not come together. I have to place. So how many letters are there? I have the other letters are D and then G, H, T, and R. So there are totally 8 letters are there. So if I don't have any condition like that, how many ways I can arrange them?
8 factorial.
8 factorial ways, obviously. Out of which, how many will have A, U, and D? No two of them should be together. That is, A and U should not be together, or U and A. It can't be this way or this way, or it can't be AE or EA, or it could be UE or EU, or it could not be AUE and so on. So all of them should not be there at all. None of them should be there. So that's what I have to count. So let's see how to count that. How many ways to count this? How many ways to count the The vowels should not be together. Any ideas?
Sir, we can count the number of ways to such that they are together and subtract it from the 8 factorial.
Okay. So they are together means I have to look at how many are there AU and UA. How many such combinations I have to look at?
Then you can
Yeah.
just check like AU, then AE, then UE, then AUE, and then just like multiplied by the number of letters factorial there.
But you
Oh,
overcount if you do it like that. You need to subtract a few.
That's what I
Hmm.
meant. Like,
I have to subtract from 8 factorial. What he is saying is that 8 factorial, I have to subtract. How many are there? Let us say, how many of them are having these two, AU together, like this, in this order?
so we can
7
consider them
factorial.
as, yes sir,
Hmm?
7 factorial.
7 factorial. Okay, that's 7 factorial. And then the other one is also another 7 factorial.
Yes
That
sir.
is UA.
So then
Similarly,
the
this
same with AE and EA. And then
that also 7 factorial. So 8 factorial, I have to subtract. This is one 7 factorial, this another 7 factorial. And then I have
the 6 times 7 factorial.
6 times 7 factorial, I have to subtract. What about AUE?
So that is 6 factorial.
Isn't that already
That,
counted?
Oh yes.
Isn't that already counted in UA?
has they been already counted or
AU?
not counted?
I think it hasn't counted.
It's already counted. When you count this AU together, you will be counting AUE together also,
Oh
right?
yes sir, yes sir.
Not one, okay, yeah, AU together again. So you, have you can't subtract that again, just like that.
Oh
Right?
yes sir.
Hmm. See, there is a small trick to do this kind of problems. Now, what I'm going to do is that, let us look at the non-vowels here. Look at the non-vowels. How many ways I can arrange the non-vowels in a row?
5
5
factorial.
factorial.
5
Five
factorial. So
factorial.
I have 5 factorial base. So for each of those 5 factorial ways, I'm going to put this AUE back here. Where can I put them back?
Oh,
I can put them in these positions.
I think I understand.
So how many positions are there? I have 1, 2, 3, 4, 5, 6. Out of these 6 of them, how many positions I have to choose?
3.
3.
3. That could be done in 6 3 ways. And how many, once I have put them in 6, once I have chosen 6 3 ways, how many ways I can place them there? That is, I have, suppose I have chosen this, one sec. Suppose I have chosen this position, and this position. I have to put A, U, and E in those positions. How many ways I can put those things in those positions?
3 factorial.
Huh?
3 factorial.
3 factorial, because I have 3 places to fill and I have 3 letters there. So it will be 3 factorial. So the number of ways is then, so I can place them in 3 factorial. So once I choose 3 ways of choosing the place where I have to place them, then I can place them in factorial 3 ways. Correct? Now this happens for every of those 5 factorial ways. So it will be 5 factorial into this one. So it is 120 into 63, 6 into 5 into 4 by 1 into 2 into 3 into 1 into 2 into 3. So these two goes away. So this is 120 into 120. So 14400. Those many arrangements are there in which no two vowels are together. Clean, right?
Sir, I have a doubt.
Mm-hmm.
You said that we have to place A, U, and E in one of those, like in those 6 places.
Yes.
So
In
you
3 places. Yeah. In
Yeah.
three of the 6 places. Yes. Yeah.
But what if they're together? Like AU is in one place.
That you don't want exactly, right? What do you want? No two vowels.
Okay.
That's what we want.
Okay. Okay, I understood.
That's what we want.
Yeah.
Isn't
Okay.
it?
Yeah.
That's what we want.
Thank you.
Okay. Yeah. So this is a very simple trick which we used. And let's look at one more problem which has a similar character. So I have, let us say, 10 books in a row. 10 books in a row. Out of this, I have to choose 4 books such that no two of the chosen books were adjacent. That means what I have to do, I have to choose 4 out of 10. Oops. I have to choose 4 out of 10. So I have 10 books. Let us say, I will, let's suppose this is my B1, B2, B3, B4, B5, B6, B7, B8, B9, B10. Okay. So I have these 10 books here. Out of this, I have to choose 4 of them. I have to choose 4 of them. That 4, those 4, oops. Yeah, so these 2. So out of this, suppose if I choose this, I can't choose this guy or I can't choose that guy. I can choose this, I can choose this, I can choose this. That way, how many choices I will have? How many choices I will have? I want to choose 4 out of 10. So if I have to choose 4 out of 10, or let us say instead of 4 out of, suppose if I have 2 out of 10.
2 factorial.
Huh?
The 10 choose 2.
Just 10 choose 2.
10 choose 2 into uh,
I want to choose 2 books which are not adjacent. Just 2 books which are
Then
not
choose 2 minus 9.
10 choose 2.
Minus 9.
10 choose 2 minus 9.
So because there are only 9 pairs of adjacent.
So this is a good thing. That is actually what he has done is that it is what is called the complementary counting. It is called the complementary counting. I want two to be non-adjacent. Therefore, suppose if I find out how many are adjacent like this, that will be 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8, 8 and 9, 9 and 10. So there are 9 choices for the books will be adjacent. So the total number of bases tends to 2 minus 9. Therefore, this will be whatever. That is 10 into 9 by 1 into 2 minus 9, which is 36. This is for 2 things. Can we do the same thing if I want 3 books out of 10? 3 out of 10.
well, if nothing changes in the question except 3 out of 10, then we can implement the same formula.
What is nothing changes? Everything is the same except that I want 3 books out of 10, which is no 2 are adjacent.
The
Then
10 choose 3 minus 7.
Why 7?
So there are 7 pairs of 3.
Very good. So that's a good mistake to make. 10 choose 3 minus 7. Is it right?
It's
There
not.
are, I think there are way less books.
it should be 10 choose 4.
Why 10 choose 4? I want only 3 out of 10. So that no 2 are adjacent.
Not right, because he's taken only into account like when they're adjacent, meaning all 3 are adjacent to each other. Like 2 could
Okay.
be adjacent and then 1 could not.
Yes,
So
sir,
suppose
then,
these 2 choose and then the other one is like this.
sir, even if we had chosen adjacent, that would have been, even if we had only considered all 3, wouldn't there be like 8 pairs of adjacent?
Uh-huh.
Sir,
No,
even
they
if
had
we had,
subtract something more or
so subtract something more, very
what is
much
that?
more, sir.
What is that something more?
I'm still thinking about that.
So suppose instead of this, if I ask, let us say I have 20 books, but I want 6, no 2 adjacent. So this will be very difficult, isn't it, in this method?
Yes,
Hmm?
sir.
Yes,
Mm.
sir.
So what do we do? In the daughter vowel not together problem, what would we do? We just, instead of choosing, we try to place them back, isn't it?
So is it
So that
minus 72 extra?
minus 7 seat extra,
No, sir, 72.
minus 72 extra. Is it?
70.
Is it 72 extra?
Sir, no, sir. The answer
Hmm.
is 10C3 minus 8.
That's all. Why 10C3 minus 8?
There are only the all three adjacent things. I don't
There are
know.
only
That's not.
There are only 8 triplets of adjacent books.
But I want no two adjacent means what? What's the meaning of no two adjacent? See, it can't be just two of them are adjacent and then one is not adjacent. Even this has to be deleted, right?
Yes.
So did you count that?
Yes, sir. I counted.
How-
That means only
how-
8 of them are there.
Oh, only 8 of them are there.
8 pairs are there, so that 3,
3,
all
4,
3 books.
5, 6, 7. Let's just hold on a minute. 3 plus 3, 6 and 10. So I will choose this. I will choose this. Then I can choose any one of these, right?
Yes, sir.
7 of them. Correct?
Yes, sir.
Then if I choose this and if I choose this, I can choose any one of these.
Yes, sir. And you can't
6.
choose the leftmost one.
That is okay, 6 of them.
Okay.
Then if I choose this and then if I choose this, I can choose this one or I can choose, this is not there. So these, again, there's 6 of them.
Okay.
So already I have counted 19.
Okay, sir.
So this won't be work, right? This won't work. So somehow we have to look at,
Sir, I think we can just do it the same way we did the daughter problem.
okay, what's the same way?
We just so like how you said, we can just put the remaining 7 books which we take out all the books, then put 7 of them back inside the shelf.
No, I
And
have 10 books and then 3. So I have 7 of the books. 7 books will remain.
yes,
So
sir.
7 books will remain. And those 7.
So the number of ways to put that is 7 factorial.
No, I don't want to put anything. What I want, I have the books arranged in the given order.
Oh, yeah, okay.
I'm
Sure.
not placing anything at all. So I have
Oh.
removed those books. 3 books, I have removed them.
Yes. And now you need to place them again back inside so that they're not adjacent.
Yes, exactly. So how will I place them?
So how many
So I have,
cavities are there? 1,
uh,
2, 3, 4,
how many are
5,
there?
7, 8.
There are 7 books, so there will be 6 in between, and 1 up and 1 before and 1
That's
after.
8.
There are 8 of them. Out
So
of which how many ways I have to place them?
3.
So I have 8C3. So there are 8C3 ways of choosing 3 out of 10. So
Which
that
are
no two
not,
are adjacent.
no two are
No two are adjacent. That's all. So suppose if I have instead of if I have 20 and 5. 20 and 5. If I remove this 5, how many will be remaining? There will be 15.
15. Yeah, 15.
And 15, there will be 14 gaps in between, one at the end, one at the
so it will be
front.
16, choose 5.
16, choose 5.
5.
That's it. So if there are n of them, and then R books I have to choose, what will be that?
So it will be 1 minute.
N plus 1.
No.
So n minus r plus 1.
N minus R
Sir,
plus
n
1.
minus r plus 1,
Because
choose r.
Choose
yeah, the remaining
R.
books are n minus r. So this will have n minus r minus 1 gaps, one at the back and one at the front. So plus 2. So n minus r plus 1. There I have to choose
Choose
r.
Okay, sir.
So to choose r non-adjacent books from n books in a row. 10 books in a row. What's the number of ways?
It will be n minus r plus 1.
N minus r plus
N
1.
minus R plus 1 CR. Correct? N minus R plus 1 CR. Okay, so this is a nice formula. So let's look at one more thing. This is from RMO. You know what is RMO?
Yes, sir. It's an Olympiad. Like the
Yes,
second
sir.
level. Second
Yeah.
level.
So for those who do not know what is RMO, this is the second level exam. So the first level exam is usually called, is called IOQM. That is, what is that? What is IOQM?
The first level.
First
It's
level.
the first
This
level
is called
to
the
INGO and all.
Indian
Indian
qualifier.
Olympiad qualified
Indian
Uh,
Olympiad
Indian
qualifier.
Indian Olympiad qualifier for mathematics. Okay.
in mathematics.
Yeah, that's correct. So this is the first level exam, which is this year around 1,25,000 students attempted all over India. Out of them, around, let us say, no more than about 6,000 or 7,000 students qualified for the second level RMO. From here, again, about 500 or something like will qualify for INMO.
INMO. Yeah.
From there, 60 will qualify for IMOTC. From there,
Then
6 will
six.
qualify for IMO. So from 1,25,000, 6 will be the one who will represent India in the International Olympiad. So anyway, so this year, I don't know how many of you are, I think you are, most of you would not have been eligible, right? If you are in 7th standard, you are not eligible. And the results have come a couple of days back. And
Sir, we
you
wrote
wrote.
the most
So
eight
did,
candidates wrote.
how many qualified?
Sir, I missed the qualification by 1 mark.
Oh, one more. Actually, if you are in Delhi region, Delhi NCR region, you are unfortunate. Because the cutoff was very high. Haryana is also very high.
The
And West
Tamil
Bengal.
Nadu region, sir.
Tamil Nadu? Yeah, Tamil Nadu was not that bad.
I missed it by 1
But sir, Maharashtra is one of the highest.
Yeah, Maharashtra is also high. These are all very strong regions. If you live in those regions, it's bad luck for you anyway. So we can't argue on that. But anyway, better luck next time. Keep trying. Okay. Right. So let's go back to now. I have again 10 books. I have again 10 books. Now what I want to do is that I want to choose again 4 books. But this time I want the books to be separated by at least 2 books. Suppose I have these 10 books, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I choose this guy, I can't choose this, I can't choose this, I can choose this.
There isn't there only one.
Hmm?
There isn't there only one way.
And I can choose this. I can choose. There's only one way of doing this, right? Obviously, because this one. Now, instead of these 10 books, I have 20 books. I want to choose 4, such that any two chosen books are separated by at least 2 books. So how many ways I can do that? I have 20 books now. Of course, you know what's the next question? I have N books and R I have to choose. Will a method like this one, which I use for no to adjacent work?
No, it won't work because in some of them they'll have a gap of 1 book only.
So
So we can try to place 20 books and try to see once, and then I think we'd be able to derive the formula.
that is correct, but how do you derive the formula?
Okay, sir. I will get back, sir.
Yes. Now let's look at the previous problem itself. I have, let us say, 10 books. 3, 4, 5, 6, 7, 8, 9, 10. I want to choose, let us say, 4 of them. So no to adjacent. No to adjacent. Now what we did was we removed those 4 books which have been chosen and then reinserted them in the gaps. Correct? Reinserted them in the gaps. Okay. So instead of that, I'm going to do something else. Now we also we looked at choose and place.
Yes.
Choose and place technique, right?
Yeah.
I'm going to use it again. We'll come back to this problem in a minute, but before that, let me see how many ways Mississippi, correct? No, this
There
is
will
wrong.
be two
Yeah,
occurrences. with
yeah,
M.
this is wrong, this is wrong, this is 1 second. This is Mississippi, correct. Okay, now there are 11 letters here.
Yes.
How many ways I can arrange them in a row?
11 factorial.
It
But
can't be 11 factorial because these S's are all adjacent. Sorry, S's are all identical.
yeah, I
Like you
think
can
it's
divide it.
11 factorial divided by 4 factorial.
11.
multiplied.
So 11 factorial divided by 4 factorial,
Factorial
4
mul-
factorial, 2 factorial,
Yeah.
4 factorial, then
2 factorial.
oh,
So because there are 2 p's, there are only 2 p's.
huh?
Because there are only 2 p's, we can.
That is correct. So why is this? Why should I divide by 4 factorial, 2 factorial?
Could I explain this?
Yeah.
Because the 4 S's are there, right? There are 4 factorial ways of arranging those S's.
Hmm.
So actually, those will be repeated again.
Okay.
So we're dividing by 4 factorial. I'm not able to explain.
Yeah. So the easiest way to see this is that I have to fill 11 slots. Correct?
Yes, sir.
5, 6, 7, 8, 9, 10, 11 slots. For those, I have to have 4 slots for yes. So how many ways I can choose 4 out of 11?
11 plus 4.
11 C 4. Once I have chosen the 4 slots, how many ways I can place them in those 4 slots?
4 factorial ways.
No, I
No,
have
sorry.
4 identical S's. So
Oh,
previously the daughter problem,
8
so I have this DH, and once I have chosen 3 ways, I have 3 distinct letters.
Only
I have
one way is there.
there's only one way of doing that. So this is the number of ways to choose, and then the number of ways to place is 1.
Yeah.
And remaining how many letters or how many places are left now?
7
I have 7 places, out of which I have to choose 4 for I.
I.
So how many ways I can choose?
11.
7, 3, 4.
7 chooses.
How many ways I can place them? 1 way.
Yes, sir.
Now how many places are remaining now?
We have 3 places.
3 places, out of which I have to choose 2 for P. So I can choose in 3 C2 ways. How many ways I can place them? 1.
1.
There's only 1 place remaining for M, it's done. So this is the number of ways of placing, arranging these letters. That is 11 factorial by, this is 4 factorial into 7 factorial. This is 7 factorial by 4 factorial into 3 factorial. This is 3 factorial by 2 factorial into 1 factorial. So this 7 factorial will go away. This 3 factorial will go away. Therefore, it is 11 factorial by 4 factorial, 4 factorial, 2 factorial, 1 factorial.
1 factorial is 1.
That is correct. So this is 4 plus 4 plus 2 plus 1 is 11. So if I have, let us say, 4 A's, 7 B's, and then 10 C's, how many ways I can arrange them in a row?
There, so give me
4 plus 7 plus 10 factorial divided by
factorial,
4
4
factorial, 7
factorial,
factorial.
9 factorial
10
and 10 factorial.
That's correct.
Yes.
That's what it is. Okay, so this is usually referred to as the Mississippi formula. Okay, so this is basically an application of choose and place. right? So we talked about two principles, addition principle and multiplication principle, and then this is the third principle, that is choose and place. Okay, right. Now let us go back to this book problem. I have 10 books in a row. Okay. Now I'm going to make a mistake in this computation now. Okay, then you have to be careful. Tell me where I made the mistake.
Yes, sir.
Okay, now what I'm going to do is that I cannot choose adjacent books, isn't it? So
Yeah.
I'm going to take this kind of dominoes, 2 by 1, with one of them black and other is white. And I have one more domino. I have one more domino. I have one more domino. So how many slots this will cover? It will cover 8 slots.
Yes.
Correct? Now I have 2 more slots, right? And for that I will have 2 single tiles like this, white tiles. Now I have 4 of one type, 2 of another. It's just like 4 A's and then 2 B's. So how many ways I can arrange them in a row? How many ways I can arrange them in a row? I have 4 A's and then 2 B's.
6 choose 2.
4 plus 2 factorial divided
But
by 4 factorial, 2 factorial. Correct?
yes,
The 6 choose 2.
6 choose 2. So suppose if I have arranged them like this. This is this tile, this is this tile, and then this tile, and then this tile. Then what are the books I will choose? I will choose this book, this book, this book, and then this book. Will they ever be adjacent? Because whenever I choose a book, the next guy is white. So that's not chosen at all. So I have.
Sir, doubt, sir.
Hmm.
Is it flipping? Is it rotating that domino by 180-degree allowed?
No, no, no. I'm going to place just this way. Just this way. That's all. That is only this fixed domino.
Yes, sir.
Sir, but what about
the number?
sir, but what about the last slot? But what if but we can't choose a book in the last slot?
Exactly. That was a mistake I'm making. So in this case, what will happen is that if I place it that way, this book will never be chosen. So what should I do for countering that one to include that also in that one?
Maybe like the domino can be arranged in 2 ways. One way is where the black is on the right. And
No, no, no. What I can do, the simplest way to do is that I will add a dummy book at the end. I will add a dummy book. It will never be chosen. Okay. So now how many slots are there? There are 11 slots now, out of which the dominoes will cover 8 of them. The dominoes will cover 8 of them. How many more slots I need?
3.
The
3
more.
white slots. Now how many ways I can arrange? Now I have 4 A's and then 3 B's in a row. How many ways I can arrange them?
Factorial
7C3. Because it is 7 factorial by 3 factorial, 4 factorial.
yes.
7C3. So this is the number of ways. So now I can choose the books corresponding to the black guys, and then that will give me, so this is 7 into 6 into 5 by 1 into 2 into 3, 35 ways. Previously also we got the same answer. Right? Now think. I have 20 books. I want to choose, let us say 4. So that the chosen books are separated by at least 2 books. Now, what modification should I make it in this?
Sir, add 2 dummy variables.
Okay.
And then we can add 3 domino things with in a
Now,
line.
after a chosen book, I need to have 2 things gap. So this is one. Yes, a domino. So 2, 3, and 4. And I have 20 books. Since I must be able to use the last one also, I must add 2 more books. That means 20 plus 2.
The 22
20
plus
plus 2.
and then
20
we
plus
need to
2.
add. Sir, we need to add 10 more B's.
Why 10 more B's?
So because four
This is
4 into
totally,
3
this is 12.
and
And
the
I should
remaining
add 10 more Bs, right? That's correct. 10 more Bs. I have to add, I have 22 slots, 22 places are there. And this will cover only 12 of them. And then I need 10 more of them. So I have these 4 As and then 10 Bs. So it will be 14 C4. 14 C4. So this kind of this tiling method is helpful in doing this kind of problems. Instead of counting the complement or things like that, this is better than that. Okay, right. Now let us, if we have understood this, by the way, any doubts anywhere? Okay, all of you are, it is morning, right? Nobody will be sleeping perhaps. Okay, all right. So let's do one problem which was from RMO. If I remember right, it was yeah, so 2015. Okay, it's one from RMO 2015. I have, let me write the statement, 28 distinct objects. 28 distinct objects are placed at equal distances around a circle. How many ways we can choose 3 out of them such that no two are adjacent or diametrically opposite. Diametrically opposite. So how many ways I can choose 3 out of them, the 28 objects around a circle. Around a circle. So how many ways I can choose 3 out of them such that no two are adjacent and also or diametrically opposite. For instance, I have this 28 and I can, so 3 of them to be chosen. So I can't choose, if I choose one, I can't choose the diametrically opposite thing also. The remaining I can choose anywhere. Okay. So let's see how to, okay, if this condition is not, this diametrically opposite condition is not there, how many ways I can choose? Suppose I am given a circle, that is 28 objects are there. I want to choose 3 out of them. How many ways I can choose 28, 3 out of 28 such that no two are adjacent?
28 minus 3 plus 1 chooses 3.
Why?
Because
28 minus 3 plus 1. Why is this plus 1?
so that because there is because we are because there is 3 one more in the end before the 28th one and after the 28th one.
So
So
I
it
think
no, here it is, see, suppose if it's a linear line, suppose I have 28, let us
that
say.
I think it's 28 minus 3 choose 3.
28, no. See, it's this, I think and all the thing comes first. You
So,
tell me the logic.
so the logic is because because the ending will be connected to the starting line. You don't need to add any extra books. So like in the
Okay.
tiling method, we give the two books thing, the tile. The second block can go to the first one, and the first block can go to the last one. So you
So,
don't need to add any extra plus one in it. Because it's
okay.
already,
But
so 28 minus 3 choose 3.
but sir, I don't
28.
think we need the tiling method because here they're talking about adjacent, not like two, the distance is not more than 1, right?
No, that is okay. Here, actually, I can use even for when they are not written, then also we use the tiling method. So
Okay.
suppose I can do this way, and then this will be a tile like this, and then this will be a tile like this, and this will be a tile like this. I would have done that, right?
Yes, sir.
So in this case, I can, okay, here what happens is that this is, I don't need extra dummy book to be added. But is it correct? See, if it is what your answer was what? 28 minus 3 plus 1 is there or not?
No, sir.
Okay, 28 minus 3, C3, right? It is 25 C3, correct?
Yes, sir.
Okay. Now let us do a sanity check. So what's a sanity check?
They're
I want
doing
to do it for a
smaller.
smaller number. Okay. Now what I want is that I have 5, let us say, only 5 are there. And I want to choose only 2. I want to choose only 2. So your answer is what? Your answer is 5 minus 2C2, which is 3C2.
Yes, sir.
So I have this is my A, this is my B, C, D, E. I can choose A and C. I can choose A and D. And then I can't choose A and D. I can choose B and D. I can choose B and E.
Wow.
Here I have 3, but I have 4 here, right?
That's 5.
Hmm?
That's 5.
There's a problem here, isn't it?
Yes, sir.
So what do you do?
So, sir, is it then the first formula you stated that n minus r plus 1 chooses r,
That's all? Okay, it is n minus, so it will be 5 minus 2 plus 1,
which is 4?
C2. It is 4C2.
Huh.
I have 6 here.
No, but there's
But are
only
there
5.
6? There are only 4, right? B and D.
There
A
also
and C,
C.
A and D,
Also C and D.
or C and D, yes. So this also is there. So I have 5 only, not 6.
C and E, I think we can.
Hmm?
1 second, sir. I think we can find more.
No, you can find, but how?
Okay, sir. That also does not work here.
Hmm. Let's go back to this 28 and C business. So I have 28 here. And this 28, suppose I don't have the condition that it is around the circle, it's a line, let us say. How many ways I can choose 3 out of 28 that no two are adjacent?
Okay.
Huh? We know that for sure. It is 28
It's a
minus 3
28 minus
plus
3
1
plus 1 is
C3,
3.
which is 25, sorry, 26 C3, correct?
Sir,
Yes, sir.
Yes, sir.
sir, I think I know why it doesn't work for the circle over there.
Hmm.
Because the number of gaps is not 5 minus 2 plus 1.
Ah.
It's a circle, right? So
Yeah, it's a
one
circle,
gap,
right?
yeah. So
Yeah.
one
That
gap
gap
should
is not the same. So 5
yeah.
minus 2 doesn't work. So let's look at this one. So I have chosen, if I just, okay, I have the circle. I just cut the circle here and then lay it out. And from there, I will check whether I can choose how many ways I can choose. 28 minus 3 plus 1. This is fine. Out of these 26 three choices, how many will not satisfy the required condition if I put it back as a circle? Let me repeat the question. So I have chosen, suppose I choose this one and something like this. So if I put this back as a circle, then also they are not adjacent, correct? So how many of them will not satisfy
Sir, when the last one and the first one.
when this one is chosen and this one is chosen?
One way, right?
If it is chosen this way, these two are chosen, I have one more thing.
The
That one more
26th
thing, no, one more thing, I could not choose this
sorry.
guy. I could not choose this guy and I could not choose this guy.
Sorry, sir. 24.
So 26 minus this 4, so 22. Sorry, 26 minus 4, this is 22. So there are 22 choices for the third element. I have already chosen 2. I have already chosen. So I have already chosen these 2, and then the remaining 22. Therefore, how many things will not satisfy? It is 26C3 minus 22. Correct? So this is the number of ways of choosing 3 out of 28 such that no 2 are adjacent. Correct? You understand?
Yes.
So this is whatever this number is, I don't care. Suppose I have n of them, n thing around a circle, and I want to choose 3 so that no 2 are adjacent. No 2 are adjacent. So I will just again cut the circle and then put this 1, 2, etc. up to n. And how many ways I can choose 3 out of this one? It will be n minus 3 plus 1, C3,
C3.
right? Out of which how many will be not okay if you put it back into the circle? I can't choose this guy, I can't choose this guy, right? So how many are there? It's minus n minus 4. So it is n minus 2C3 minus n minus 4. Hmm?
So the formula is for this one is
Hmm.
n minus r plus 1 chooses r
Hmm.
minus n minus r plus 1.
Hmm?
Sir,
N
it's
minus
n minus r
Hmm.
n minus r plus 1
Hmm.
C3
N minus
minus
Hmm.
n minus
Or minus 1.
N minus R minus 1.
huh.
Yes, sir.
Okay, so this looks like a bit bad, meaning that is
That
very
means
hard to remember. So let us look at this way. This is n minus 2 into n minus 3 into n minus 4 by 6 minus of n minus 4. So I will take this n minus 4 out. The remaining thing n minus 2 into n minus 3 by 6 minus 6 minus 1. Same as n minus 4 into n minus 2 is n square minus 5n plus 6 minus 6 by 6. So this is n minus 4 into n square minus 5n by 6. It is same as n minus 4 into n minus 5 divided by 6. There is some issue here. What's the problem? Hmm?
So could you go down, please?
Yeah. Is this correct?
So instead of cutting it up, like why can't we just see it in a circle? Like if like let's take an example.
Uh-huh.
Like if there are 16 points and we have to choose 3,
Hmm.
so then we could draw 13 circles.
13?
Yes. And then the number of gaps, wait. Yeah, there would be gaps in between them, right? The number of gaps would be 13.
Number of gaps would be 13.
Like
Yes.
instead of, yeah, so then we could just do 13, choose 3.
Just 13 choose 3.
Mm,
Does it work for 5 and 2 or 6 and 3?
I'll try it out, sir.
Yeah. So anyways, you just do sanity checking. This
Well,
looks like an
can't we do like how we did in the line like this? Then the line we did n factorial times wait 1 second, sir. We did n factorial times n minus
No. Say that again. N.
factorial. Sir, in the line we did n
In
factorial.
the line, suppose I have the line n. I want to choose 3 means it is n minus 3 plus 1 C3, right?
Yes, sir.
Out of which, how many things I have to delete? This guy, both are chosen means I have n minus 4 choices of this one. So if both are chosen, third choice has be only n minus 4. So I subtracted n minus 4 here.
Yes, sir.
That looks perfect.
Yes.
Okay. And whether this will work for instead of 3, if I have 4, if I have 5, or if I have R.
If we have 4 books, sir, then the remaining n minus 4, we have to place 2 books such that they are not adjacent.
Exactly, that we can do. Very good. Excellent, excellent idea. Now, this is not a good formula to remember. So I'm going to do something different there. I have tried it as n into n minus 4 into n minus 5 by 6. Now, I will just add and meaning multiply and divide by n minus 3 divided by n minus 3 into this factorial 3. Now, can you guess what is this?
N minus 3 choose 3.
Yes, so it is n by n minus 3 into n minus 3 choose 3. Here's the number of this. It's very nice. So now I can guess that if I want to choose r of that like this, it will be n by n minus r into n minus c n minus c r c r. This is the number of ways of choosing r such that no two adjacent around a circle. Okay. Anyway, we will not go into this proof. We will just go back to our RM 2015 problem. Now I have 28 of them. I have to choose 3 such that no two are adjacent and no two are diametrically opposite as well. Or diametrically opposite as well. Now let me look at how many are not adjacent. That formula I already know now. This is 28 by 28 minus 3 into 28 minus 3 C3, which is same as 28 by 25 into 25 C3. Sorry, 25 C3.
Yes, sir.
Out of this, how many of these will have two diametrically opposite? So I have this circle, which contains 28 points. Suppose if I choose this one and a diametrically opposite point, this one, where all the third can happen? Where all the third can happen? Since I have already chosen only non-adjacent ones, I cannot choose this. I cannot choose this. I cannot choose this. I cannot choose
You
this.
can't choose like 6 points. It'll be 22.
22. So for this choice, I have 22 of them. For suppose instead of this, I chose, let us say, I chose this one and a diametrically opposite for that one. For that also 22.
Yes.
So how many such diameters are there for 28?
14.
Note that actually there are 28 diameters, but this diameter will be chosen once here and once here, so I have to choose only 14 diameters. So the answer is it is 28 by 25 into 25 C3. How many I have to subtract? Each
22
diameter
into
22 into
14.
14. 14 I have to subtract. So this is actually 28 by 25 into 25 into 24 into 23 by 1 into 2 into 3 minus 22 into 14. This 25 goes away. This is my 4. So this is 28 into 4 into 23 minus 22 into 14. Let's check what is that.
So could you move back up to the question once, please?
Yes. Here.
Okay, thank you.
So
Yeah.
I didn't look at the numbers which you had shown before to multiply.
Yeah. So here the number is just this 28 into 4 into 23 minus 22 into 14. So 22 into 14 is what? 28, 308. And this one is 92 into 28. I am a bit
I think I got 1466, but
uh,
I'm not sure.
675 2576 2576 minus 308, which is 682268. There are 2268 choices for 3 objects, such that no 2 are adjacent and then no 2 are diametrically opposite. So as a RMO problem, in fact, it is much easier, meaning it is not actually an RMO problem. Actually, this could have been even in IOQM these days, because back in 2015, the problems are of slightly lower level difficulty. Right? Nowadays, this kind of problem will come in IOQM, not in RMO. Okay. But anyway, so to summarize, since we have only very less time, so 10 follow up. So very less time. What we did today is that we just looked at multiplication principle, and then we looked at choose and place, and we also looked at the domino model. Okay. So as a combinatorial as a subject is extremely exciting one, which looks at even though the problems look simpler, sometimes it becomes a bit more complex because you need the right idea to do this. Even in this case, for instance, you need to cut the circle into a linear line and then apply the known result and do that. That's one way of doing that. And you can wonder whether is it possible to do the domino style proof for this also, for the circle also. Okay. Yes. But it requires a bit of some hard thinking is required. There is one small thing which you have to take care. That is, once I put the dominoes, how many times the choice will be counted? That we have to decide. Once you do that, the formula of n by n minus r into n minus RCR will automatically flow out. Okay. So anyway, so that's where that's okay. Here we will stop, and hope you found it useful and exciting. Okay. And again, we will meet again in another class sometime. And thank you, and all the best for all your exams and so on. Okay.
Thank you, sir.
Thank you. Bye-bye.
Thank you,
sir.
sir.
Thank you.
Bye.
To the amazing world of combinatorics. And introducing us to the addition principle and the multiplication